Okay, here's another example of finding the area of a fan-shaped region. We've got r almost as a function of theta, so we could solve for r if we took the square root, right? R is equal to plus or minus the square root of 2 sine 3 theta. So in order to think about this shape, we need to know, okay, if we want the area inside this whole rows, how far are we going to have to integrate? Well, remember that sine 3 theta is sine going 3 times faster than it normally does. So normally it takes 2 pi to get everything done, but this is going to do everything in 2 pi over 3 because it's working faster. So halfway in between there would be pi thirds, and halfway between that would be pi sixths, and halfway between that would be pi halves. So we have sine. It's going to start out at 0. Here's 1, here's -1, here's 0. Sine's going to start out at 0. By the time you get to pi 6, it's going to be to 1, and then by pi thirds it'll be back down to 0. Okay, it's the usual graph of sine, only speed it up so it's going twice as fast. Oh, also, it's 2 sine 3 theta. So what we need to do, this should be 2 here. The amplitude is 2. So this is what the sine curve would look like. Then remember, r is equal to the plus or minus square root of that. Now we take the square root of these parts where the sign is negative, you're not going to see anything. There won't be anything there. But taking the square root is actually going to make this kind of a little bit more squat, because the square root of 2 is only about 1.4. So we got the square root of 2 there for our maximum. And then these points are all going to kind of bulk out a little bit. Now we also have to consider that while we're doing that, we also have r equals the negative square root. So we're going to see a shape like this. Now each of these is going to make a leaf as we turn from 0 to pi thirds. So I'm going to start out here turning from 0 to pi thirds. The upper curve makes a leaf, starts at the origin when you're at 0, and you're back at the origin by pi thirds. And when you're at pi 6, you have the maximum radius, so you have like a big leaf here, right? At the same time, you're going to make another leaf back behind. So if we extend this line pi 6 here, while you're facing into the first quadrant, having these negative radii just come back and they draw another leaf right there. Okay, so then this pattern's going to repeat. You're going to take a break, right, and then you're going to come back with the same graph again. So you'll have another leaf here. So that's going to make 2 more leaves, and then you'll take a break, and then you'll come back and have another leaf. And so when you're all done, that's going to draw in, next stage is going to draw in 2 leaves here, and then the next stage is going to draw in 2 leaves there. So yeah, you're going to get a 6-leaved rows. Now there's a symmetry in here, so all the petals are the same. We just need to find the area of one petal, which we could do if we just integrate. So theta from 0 out to pi thirds, right? That's enough time for us to draw the upper petal of the leaf. Now remember, the formula says 1/2 r squared, and we already have r squared is 2 sine 3 theta. So the area of this leaf is going to be the integral from 0 to pi thirds of 1/2 r squared. But r squared, we're told, is 2 sine 3 theta d theta. That's going to find the area of one petal, right? Oh, and it's a 6-leaf row. So if we find the area of one petal, then we need to multiply by 6. So basically, this 1/2 cancels that too, and we have 6 times the integral from 0 to pi thirds of sine 3 theta d theta. Now, the antiderivative of sine is cosine. So let's see, or is negative cosine. So we're going to need a -6 and we take the derivative of this cosine, it's going to throw out a negative sign. That'll take care of this negative, and then the chain rule says you'll have times 3. So I'll have to divide by 3. There we go. So we need to take that antiderivative and evaluate it between 0 and pi thirds. So we have negative 2 times the cosine of 3 theta between 0 and pi thirds. So we have negative 2 times the cosine of 3 times pi thirds would be pi, minus minus 2 times the cosine of 0. So I wrote theta there. Okay, now the cosine of pi is negative 1, and the cosine of 0 is 1. So negative 2 times negative 1 makes 2. Minus minus 2 would be plus 2. So the area is equal to 4.